Alright, y'all. What we're doing today is a little bit of review for these questions if you're struggling with Worksheet 3. Now, if you notice, I'm skipping 1 through 4, mainly because I don't want y'all so worried about doing these graphs and highlighting for these inequalities, right? What I want us to focus on is that second part on 1 through 4, where you're solving algebraically. So I'm just going to do 6 through 10 here. The biggest thing here is before you make any decisions, before you start splitting up your equations, you always need to start by isolating your absolute value. So in this case, we're isolating that absolute value of x plus 4. So I'll put isolate x plus 4. Right, now to isolate that absolute value of x plus 4, we need to move, let me erase this for a second, we need to move this negative 1/2 that's sitting out in front. Right, now there's two ways to do it. You can either divide by negative 1/2. If you want to divide by fractions, that's absolutely okay. Or the other way you can do it is by multiplying by its reciprocal. Now again, the reciprocal is just that 1/2 flipped on its head. So we multiply by 2 over 1. And since that's a negative 1/2, we multiply by a negative 2 over 1. Right, what you do to the left side, you do to the right side. Okay, that's what cancels out this fraction out in front. Now we're left with absolute value of x plus 4 by itself. That is isolated. Perfect. 10 times negative 2 is negative 20. Divided by 1 is still negative 20. So we still have a negative 20 on this right-hand side. And the biggest thing here is since we just multiplied by a negative, remember, anytime you multiply or you divide by a negative when you're working with these inequalities, that's got to switch. Right, so now it's going to be a greater than. So I'll put let's do like this. Anytime you multiply or divide by a negative, flip the inequality. Right, that's huge. But we end up here, right? And this problem is actually pretty nice. We end up right here. We have our isolated absolute value of x plus 4. It's saying it's greater than negative 20, and we're done. Right? We can stop at this point. Don't go any further. Don't start splitting it up into two equations. Anytime you have an isolated absolute value and a negative on the other side, it's a special case. Right? So it's either all real numbers or no solution. And we just have to determine which one of those it is. Keep in mind, no matter what goes inside of this absolute value, it's going to come out as a positive number, right? No matter what that number is, absolute values make it a positive number. So what this is saying is there's a positive number and it's greater than negative 20. So then it asks the question, is a positive number greater than negative 20? And hopefully you're thinking, yeah, Everly, positive numbers are always greater than negatives, and that's true, right? Positives will always be greater than negatives, hence this is all real numbers here. Okay, now if you don't want to remember that logic there, then just think absolute value greater than negative, that's all real numbers. Biggest thing though, you have to isolate it first, then you can determine that it's a special case there. But that's number 6 done for you. Alright, so here's number 7 from the homework. Again, the difference here was you had to start by setting up f of g of x. Right, this part right here. So I'm just going to go off to the side and set that up. Right, so we have f of x equals the absolute value of x, g of x equals 4x plus 1. And we're tasked to set up f of g of x. Right, so if you don't remember how to set up this function here, it's a composition of function, which means we're going to take whatever g of x is, which in this case, 4x plus 1, and plug it inside of f, right, because g is inside of f. So how we do that is f of x is the absolute value of x, right? That's what f of x is, absolute value of x. But instead of writing x right here, we're going to replace it with 4x plus 1. That's what we're plugging in. We're substituting that in for x. So we're going to go 4x plus 1. That is f of g of x. Let me rewrite it so we don't have as much colors going on there. Absolute value 4x plus 1. Now the hint there is just make sure you end up with an absolute value. That's all we're working with in this unit, so we shouldn't really get anything that looks different. So I'm going to now take absolute value 4x plus 1 and substitute it in right here into this equation. So we have absolute value of 4x plus 1, still minus 14, is less than negative 5. And now we're set up with a problem just like number 6 that we can solve. So what we do is isolate that absolute value of 4x plus 1. So we're going to add 14 to both sides. We'll end up with the absolute value of 4x plus 1 is less than negative 5 plus 14 is positive 9. Now that's an isolated absolute value, and we split it up. Right? We get to this point, we check is it no solution, all real numbers. We can't say anything because it doesn't have a negative here. That's when you determine that. So since it's just a positive 9, we break it up. Right? The two equations, right? The first one, 4x plus 1 is less than 9. It looks exactly like that equation there without the absolute values. The second equation, still 4x plus 1. It's just now we're taking this less than and we're flipping it to a greater than. We're taking that positive 9 and flipping it to a negative 9. Those are your two cases. Make sure when you're doing this you end up with a less than sign and a greater than sign for those problems. That's a good way to check to make sure you're on the right track there. You should never have two less than signs, is what I'm trying to say. From this point, you're solving for x, right? So just take it one at a time. I'm just going to go minus 1, minus 1. We go 4x is less than 9 minus 1 is 8. We don't flip the inequality there because that's not multiplying or dividing by a negative. That's the only time you flip the sign. Divide by 4, and we go x is less than 2. Let's do the same steps over here. Again, minus 1 on both sides. 4x is greater than negative 10. Divide by 4, and we got x is greater than negative 10 over 4 reduces to negative 5 over 2. So that's how I'm going to write it. Always reduce your fractions when you're working here. Those are our two inequalities. So now what we're going to do is set that up on a number line to figure out how do we write our final answer. So we have our number line. Okay, we have two values of 2 and negative 5 over 2. 2 has to be to the right. Negative 5 over 2 has to be to the left because it's less than 2. From this point, just graph it one piece at a time, right? Let's start here. X is less than 2. First thing, at 2, we leave it as an open point because it's not less than or equal to. It's when it has the or equal to's, that's when you actually fill in the point. So, open point at 2. Second thing, which way do you graph? It's a less than sign pointing you to the left. So we're going up and go to the left. Now notice how we're going towards that negative 5 over 2. So we're not going to draw an arrow there. Now let's work with the negative 5 over 2. Okay, same logic, right? At negative 5 over 2, we go over here, we put an open point. It doesn't have the or equal to, so it stays open. Then you look at that inequality. Since it's greater than, that's pointing you to the right. So you're going to go up to the right. And look at what happens here. We have that overlapping section telling us that our answer is in between these two numbers. So this number line is one of your answers. You do have to make sure you graph it on a number line. The second thing is whenever you have a graph that goes up and in and it's overlapping or the x is in between, that's when we write our compound inequality. Right? We do the compound inequality, and what it looks like is negative 5 over 2 is on the left, so negative 5 over 2 is going to be on the left for our inequality. 2 is on the right, so 2 is going to be on the right. We're talking about x, so what that's saying is x is in between negative 5 over 2 and positive 2. These are always going to be less than signs. The only thing that might change is had this original problem been less than or equal to, then we would put the or equal to there. So we just leave it as the less than signs. That's your answer. What that inequality is saying is x has to be in between -5/2 and 2. What that graph is saying, x has to be in between -5/2 and 2, right? So that's how you end up answering number 7 there. All right, here we go, y'all. Number 8, this one's going to be a tough one. Hunker down, grab your popcorn. We're going to be here for a while. Yeah, I wish I could make better jokes, but that's a grade A tier joke for Everly. What you do here is, first, every time we have a problem with the absolute value, isolate the absolute value. But notice the absolute value of x is already isolated, right? So this is already isolated. Okay. Once you've isolated it, that's when you break it down to the two equations. But anytime you have an isolated absolute value and it's a negative on the other side, stop. Right, we're done here. It's a special case. It's either all real numbers or no solution. So we just have to figure out which case is it. How I like to think about it, again, is no matter what is in here for x, absolute values are going to make that a positive number, no matter what. So what that's saying is there's a positive number and it's less than -6. So ask yourself the question, is a positive number less than -6? And hopefully you're like, what? Positive can't be less than a negative. It can never happen. No, which means this is no solution. Right? Positives can't be less than negatives. Anytime you have an absolute value, no matter what's inside of it, if it is less than a negative, once you've isolated it, you can just stop and be like, oh, that's no solution. So that problem's done. You don't have to worry about doing a number line there for special cases. You're good to go. All right, so here's number 9. Again, very similar to one of the previous questions that we looked at. We just have to start by setting up this g of f of x. So let me go off to the side, kind of write out some of our information, and then we could set that up. Okay, so we have g of f of x. That's what we're setting up right now. Again, it just becomes which function is inside. Right? In this case, f of x is inside of g. So we're taking whatever f of x is, 7 minus 2x, and we will substitute it inside for x in g. Right, so g of x originally looks like this. Absolute value of x, but instead of writing x, we're substituting in 7 minus 2x. Okay, so this is really telling us that g of f of x is the absolute value of 7 minus 2x. I'm just going to rewrite it so we have it without like the box on it. There we go. So what we do now is go back to this original problem. It tells us to solve 2 times g of f of x minus 1 less than or equal to 37. We're literally taking 7 minus 2x right now, substituting it into this. So we should end up with still 2 out in front. Instead of g of f of x, we are writing absolute value of 7 minus 2x, still with this minus 1 less than or equal to 37. And now that is set up just like the problems that we can go through and simplify for, right? We need to now isolate absolute value of 7 minus 2x, right? To isolate that, we add 1 first. That gives us 2 absolute value of 7 minus 2x is less than or equal to 38. Divide by 2. Absolute value of 7 minus 2x is less than or equal to 38 divided by 2 is 19. Now it's isolated. Once you have it isolated, this is when we break it into its 2 equations or determine if it's a special case. It's not a negative on the other side, so it's not one of our special cases, which means we do have to go through and set up our 2 equations. Right? The first equation, 7 minus 2x is less than or equal to 19. It looks exactly the same as that original one with no absolute values. The second equation, 7 minus 2x, again, but now we flip that to a greater than or equal to, flip that from a positive 19 to a negative 19. Those are your two equations. Now we can go through and solve them independently. So just start on the left. Right, we start by moving this 7 that's out in front. To move that positive 7, we subtract 7. So we end up with negative 2x less than or equal to 19 minus 7 is 12. Divide by negative 2, and we end up with x. 12 divided by negative 2 is negative 6. And because we just divided by a negative, that less than or equal to flips to a greater than or equal to. So just make sure to flip that sign anytime you multiply or divide by a negative. That's your first inequality. The second one is going to follow the same steps, right? Subtract 7. We got negative 2x is greater than or equal to negative 26. Divide by negative 2. We got x is less than or equal to 26 divided by 2 is positive 13. Again, we had to flip that sign because we divided by a negative. Those are our two inequalities. Right, now before we write our answer, let's graph it so we can see how we're supposed to write our answer. So I'm going to go over here on our number line. Again, we have two values, so you have two numbers. 13 is on the right, negative 6 is on the left because it's less than 13. Let's start with this. Negative 6, we go to negative 6, so I'm going to start with an open point. We look, because it has that or equal to, we actually are going to fill in the point. Because it is a greater than negative 6, that means we're going to the right. So we go up to the right, and it looks like we're going to have one of our graphs that go up and in. Now let's do 13. We look at this. At 13, again, we fill in the point because it has the or equal to. And then less than is pointing us to the left, so we're graphing to the left of 13. We go up, we go in, we have this overlapping graph right there telling us that our answers lie in between negative 6 and positive 13. That's your graph on a number line. Anytime you have a graph that goes up and in like this, you have to write a compound inequality. How you write that, again, is the number on the left, negative 6 is on the left, the number on the right, 13 is on the right. We put x in between because that's the variable we've been dealing with this entire time, telling us x is in between negative 6 and 13, and these are always going to be less than signs. The only thing is, we filled in the points. This original problem was or equal to, so we just make them less than or equal to's. That's the compound inequality, telling us that our answer lies in between negative 6 and 13, which is what our graph is showing as well. Okay, so here is the last question for numbers 6 through 10. Again, I didn't do 1 through 4 because I don't want you so focused on the highlighting part for 1 through 4. I need us to be really proficient at solving absolute values. So on number 10, what we're going to do is isolate the absolute value of 1/7 x plus 2, which means we're going to start by adding 5. Okay, we have absolute value 1/7 x plus 2 greater than 8. That is isolated. Once you have isolated it, this is when we're like, oh, is it no solution? Is it all real numbers? No, right? What determines that is if there's a negative. So we can't even think about the special cases, which means we move on, right? This is when we break it up into the two equations. Your two equations. The first one, 1/7 x plus 2 is greater than 8. Looks exactly like the original without absolute values. The second equation, 1/7 x plus 2, that's the same. Flip that from a greater than to a less than. Flip that from a positive 8 to a negative 8. Now we have our two equations, which we will solve independently. So I'm going to go on the left here. We start by subtracting 2. 1/7 x is greater than 6. Notice how we did not flip the inequality. You only flip it when you multiply or divide by a negative. To move this 1/7, we multiply by its reciprocal. right? That means we multiply both sides by 7 over 1. Fraction's gone. We're left with just x is greater than 6 times 7 is 42. Divided by 1 is still 42. So we get x is greater than 42. Now let's solve that one on the right. Subtract 2, subtract 2. 1/7 x is less than negative 10. Multiply by the reciprocal. Multiply by the reciprocal. That's gone. We got x is less than negative 10 times 7 is negative 70. Divided by 1 is still negative 70. There's our two inequalities, which we can now graph on a number line. So I'm going to draw our number line. Again, we have two values of 42 and negative 70. So make sure you have negative 70, 42. And we'll just start with this graph. We go to 42. We graph the point. We do not fill it in. It is just greater than. It doesn't have the or equal to, so it stays open. Then it becomes, since it's a greater than, we graph to the right of 42, right? That's where the numbers would be bigger than 42. So in this case, we're going up and out. Now we'll do the same thing with the negative 70. At negative 70, it's an open point. Doesn't have the or equal to. Since it's less than, it's pointing us to go to the left, so we're going up to the left. That's where our numbers would be less than negative 70. That right there is your answer on a number line. And to finish this off, we just have to figure out, do we write it as a compound inequality, or can we just go like this and put or in between? And in this case, when they go up and out, if you just want to remember, you can put or, you're done. Those together are your answer, right? So your answer is x is greater than 42 or x is less than negative 70. That's when they go up and out. The little trick that I had to remind y'all, and I'm just going to take this opportunity to get a little art in, is the easiest way to remember that it's or. What I like to remember is, imagine this is a little rowboat. Oh yeah, here we go. Here's our captain. Give him a little hat. Yeah, I think that's how they look. And then here's their little like pirate flag. Yeah. So that's a boat. Those things going up and out. These things right here. Those are the oars of a rowboat. Hence, we have to put or there. The biggest thing is when they go up and out, you have to make sure you put or in between your answers. But that finishes up number 10. Again, I just wanted to focus on solving algebraically. I did not go through 1 through 4. If you had issues graphing those, then you could talk to me in office hours, send me an email. But hopefully this helps you out.